everyone, I'm Sarah, and these are my colleagues, Sarah and Gustav, and we work at Connected Services at Scania. So we are here today to talk about how to create value within a big organization. So I will start by telling you some of the challenges and opportunities that you meet within a big organization. And then we'll continue talking about why you need to approach this with a DevOps fashion in order to create value. And in the end, we'll show you some technical details, some of the tools that we used to create value. And we will also show you some hands-on Ansible coding. Ansible is one of the tools that we found very useful for us. So everything that you will see today has been created within a research project called FUMA, and it's done in a collaboration between Scania and our partners, the Fraunhofer Chalmers Center in Gothenburg, and it's sponsored by Vinnova. So Scania is a very old company. For more than 120 years, we've been in the business of transporting goods and people. So the first trucks was produced in the beginning of last century. And since the 50s, we are not only operating in Sweden, so we are a global company. And we not only produce truck, buses, and engines, we also own quite a lot of large extent of our workshop network. So in the beginning of the 90s, we had approximately 50 workshops that we owned ourselves, and currently we own more than 500. So in the beginning of this century, we started to provide our products with the possibility of being connected. And that's the start of a new journey for the company. We are no longer just a manufacturing company. We are trying to be an important player within the entire transport system. And the vision for the company is to be an important player in the shift toward sustainable transport solutions. And one important ingredient in doing that transformation is, of course, data. So, of course, all our products should be connected, and that's the company's strategy. And as a consequence, we have more than 300,000 connected vehicles running on a daily basis. Here you can see one position from each vehicle that was connected during May last year. But it's not enough to just connect the vehicle. Of course, much more activities are ongoing to reach the goal of a sustainability in the transport system. One of those things is electrification. So, and to reach that, we have currently partnered up with a company called Harvey, and they had a problem. In Stockholm, it's not allowed to drive heavy vehicles during nighttime for delivery. And Harvey, they are delivering food to McDonald's restaurants. And they have a need to deliver during night. So they come to us with a problem, and we decided to partner up and to try to solve this. And currently we are running a test where we use positioning to control where the vehicle should run purely on electrical power. That's why we are reducing the noise levels, and they are allowed to operate during nighttime. And it's good for the drivers. They get to drive in an almost completely empty city. It's good for the people of Stockholm because they experience less congestion, and it's good for the globe because we have less CO2 emissions. So, but what we are doing now in the company to reach this goal of becoming data-driven, of course, demands data. So here you can see different part of the organization where data is created. And previously, the strategy or the principle that was in the company was that the one that produced the data owned the data. So it was treated as secret even internally. Completely stupid, but that was the way it was. And then we decided upon a data sharing rule, that data should be available for operational and analytic use, minding legal aspect. And this led us up to a data lake that we have today. It's an Hortonworks Cloudera data lake that we have run since 2016. And connected to that, we have a central team of excellence. They are responsible for keeping the lake alive, up to date, and adding new data sources. They are also responsible for data management, data information, data governance, and they also have data developers and data scientists that they can lend out to the organization that has need for it. So, Is it a straight road now from here to value? We have data availability, data capabilities, and we have a vision to become this partner in the sustainable transport system. So it's not really so that we create value with a vision. We have to break that vision down into reachable assignments that actually you can do. So how to do that then? Within the organizations, there are a lot of people, and a lot of people have a lot of needs. And that's, I find, one of the most interesting and rewarding part of being part of a big organization is that you constantly get to hear new needs. You get to learn from your colleagues. So, for example, they can come with us with questions about how to create the next gearbox. Could you participate in the product development of that? Where to place the next workshop to make that as profitable as possible? The breakdown that we see on the road, what's the root cause behind that? And the next service for our connected customers, what should that contain of? And all of these are valid questions. All of them could be answered with data. So they are right to come to us to ask us that. So, however, it's easy to get distracted. That's one of the challenges, I would say, within a big organization. So, and it's the best way of getting nothing done is to do a lot of things simultaneously. So you have to kind of neglect people talking to you. And one more thing that is a challenge within this organization is that we have a history. And of course, we are proud of the history. That's why I started today talking about the Scania history. But the history is also a little bit problematic when it comes to data products, because everyone will explain their need based on where their previous journey ended them up in. So the same need will be explained in different manner depending on where you are in the organization and depending on which data products you have today. And the same need will also be explained to different people. So the possibility or risk, if you say that, of creating the same solution more than once is massive within a big organization. So how to do that? The first thing you need to do is select. Select the use case that you want to work with and select that wisely. So you need to sit down with a lot of stakeholders, understand their problem, and select to stick to that one, and stick to it until you reach production. The second thing you have to do is when you select, is you have to make sure that someone is actually willing or acting on the results that you get out of your data product. And if possible, select a use case where someone with very much mandate within the company is interested in finding the results that will make things much more easy for you. The next thing you should care about, I would say, to create a lot of value within the organization is to prepare for reuse. Often, as I told you before, you have the same need at different parts of the organization. And if you create your data product to be able to reuse it, then you probably will end up reusing your solution. And in order to reuse, you have to make a solution that is modular, to use part of the solution to solve other needs in the organization. And you also have to make everything reproducible in order to be able to reuse it. And then, of course, you need to spread the word. You need to have someone that is the spokesperson for your solution that gets out to talk to people, to understand if their need could be solved with the solution that you created. And the last thing I would say, of course, is important in order to create value within an organization is to work smart. If you don't work smart, you will never reach the solution in production and, of course, not create value at all. And we believe that you have to work in a DevOps fashion. And my colleague here, Sarah, will continue to talk about how to work once you have selected the use case to work with. So, shoot.
Okay, so I want to start off with introducing you to Peter. Peter is a manager at Scania's internal logistics department. So Peter had recently received some reports stating that the locations he was responsible, the locations at our factory site, when we produce our heavy trucks, were having some logistical challenges. So when we became aware of Peter's problems, we decided that we should help Peter. So we realized something, that when creating a solution, catering to Peter's needs, that's much like planning a journey. And planning a journey, like any other journey you would plan for in life, requires a map. Okay, so this is a map, and it represents Peter's map. So Peter had this destination. He wanted to understand these deviations at his pickup and delivery locations. And he had a journey planned for us, a solution that he thought we would create for him. So he thought he needed something where he could visually explore all the GPS data for his vehicles. Okay, so we created that for him. So here you can see a dashboard showing you all the GPS data for one of Peter's vehicles. So when we came back to Peter with this, he wasn't really satisfied because he couldn't understand his challenges. But he suggested that if he were only able to see all his vehicles' data on this map, that would probably help him. Okay, so we did that. And here we can look at all the GPS data from our manufacturing site for all of Peter's vehicles. So when we came back to Peter this time, I'm fairly sure you understand this as well, because he couldn't understand what was causing him any problems and where and when. And we came back to Peter, and this time he suggested that if we could utilize our global data, that would probably help him. Because as Sarah mentioned, we have more than 300,000 connected vehicles. So maybe if we make sure that he could look at all that data, he would understand a pattern. Okay, so we did that. And surely you still understand this didn't help Peter. Okay, so we came back to Peter with this the third time, and he suggested that maybe if he could just, and that's where we decided now is really time to take a step back. So remember Peter's map? We have this destination, a journey that is the solution catering to Peter's needs. But the journey that Peter had planned for us, that's probably going to end up taking us somewhere we don't want to be, because this is a plan on an empty map, because this map is missing its terrain. So we, as developers, we have another map. We have all the technical possibilities and limitations, and we also have the necessary travel experience, so we can navigate the terrain when creating a solution. But we don't have a destination, so we don't know where we want to go. So we have to merge these two maps in order to actually create a valuable solution for Peter. So we have now technical possibilities and limitations, and we also have a destination where we want to travel. But in order to actually make the journey, we have to have a full breakdown of the journey, because creating a solution is much like planning for the right equipment. So in this world, in that map, that would require us having a car, because it's quite far to travel without it. And we would need to have some skis, because there's this snowy mountain that we need to pass. And coming up, there's this misty forest, and we need some navigation tool, so a compass. And there's the sea we need to cross, so having a boat, pretty awesome. And coming up at our destination, there's this locked gate, so we definitely need a very specific key. And all the while understanding that we have to have all of this in place, we also have to understand that we as developers, we have to make this journey more than once. And the key to actually do that, that's automation. So incremental improvements and working in an iterative process, that's what's going to enable us to create a data solution that is viable when our world changes. And it's also the thing that's going to enable us taking feature requests from Peter. So when Peter decides to add a destination to our world, we will all be able to use our common railway to end up where we want to be.
We'll continue talking about this common railroad from a more technical perspective. So we failed to meet Peter's needs by simply showing him all the positions So we realized that we had to create a solution that processes the position information into meaningful aggregates. So we decided to model this solution as a series of Spark Streaming jobs, interconnected with Kafka topics. This gives us simplicity, as each processing step is isolated into a separate Spark Streaming job. It gives us modularity, and we can reuse parts of the pipeline to solve similar problems. And it's transparent, and we can access and verify intermediate results and the final result. And of course, it's scalable, so we can add workers to the Spark Streaming jobs and partitions to the Kafka topics. So we decided early on in the project to use streaming, and why did we do that? Basically, batch processing gives slow feedback. Especially big batch jobs are hard to debug. It's very hard to fix performance issues. You may get some strange out-of-memory error, and it's very hard to nail down what part of the batch went wrong. So it scales unpredictably. If you add 100,000 records more, will it still work or will it fail? You don't really know. Streaming, on the other hand, it scales predictably. If it works, it just works. It will take longer time if you have more data, but it's predictable. And if it fails, you can restart from where you were. In a batch program, when it fails, maybe you lost half a day's work. Streaming, on the other hand, has more moving parts, so it has a bigger requirement for automation. You may challenge this and think that, okay, but I can develop my batch program with fewer records. Then I have a faster development cycle. But after all, it's big data, and you want eventually to test, can I run this batch job on a terabyte of data? And you do that, and you run it for several hours, and maybe you get a mail from the admin saying that you're stealing half of the cluster resources. Are your job going to finish, or is it doing something valuable? Has it hang? And you say, well, I don't know. Maybe if I run it some more hours, we'll get a result. And after 2 hours, it fails, and you get an out-of-memory error. And yeah, how should you fix this? So streaming then. What is streaming? Fundamentally, streaming is about having a distributed log store, which is append only. So it's a really stupid database where you can only add to the end, and you can read from a certain point, but it does this really well. And compared to a queue, a stream is partitioned, and this is what makes it possible to do parallel processing. But you need to realize that you need something to partition on. So in our case, we use some entity ID from the vehicles to partition on. So yeah, this is what Kafka is actually. And then you need a processing framework. And we have chosen to use Spark Streaming since we have this on the data lake. There are basically two types of streaming frameworks. One is called Spark Streaming, and the other one is called Structured Streaming. Spark Streaming is the older API. It's basically a stream of RDDs. So you program much like you would program on the RDD API. Then you have the Structured Streaming. It's based on the newer data frame dataset API. It has the benefit of using the Catalyst optimization engine, which is nice, of course. It's more declarative, and you say more about what you want to do instead of how you want to do it, because that's what Catalyst figures out for you. We have found that the Spark Streaming API perhaps is a bit more mature, and that it's easier to monitor Spark Streaming jobs compared to structured streaming jobs. It's an opinion, and it may be something that we have missed. So, we have a simple, modular, transparent, and scalable solution, but still, running a single Spark Streaming job requires several steps. We have to build the code, copy the binary to the driver node, set up the Spark submit with all the options and all the parameters. And since we're also using Kafka, we have to manage the Kerberos key tab files, JAWS configuration files, and all the checkpointing. So doing this once, it's possible, but doing it several times, no, it's simply not reproducible. So we have decided to automate this using Ansible. Ansible allows us to run a single Spark Streaming job as a single version handle command. Ansible also allows us to keep all the parameters in environment-specific inventories, so that going from one environment to another can be done simply by changing the inventory file. So going back to the developer map that Sarah talked about earlier, and the snowy hill, Ansible is like the automated packer that packs our backpack so that we can pass this mountain reproducibly every time. Okay, so Ansible then, what is it? To begin with, it's agentless, and this means that you only need to install it on the controller. So you only need to install it on the Jenkins master, the Airflow master. You can run it from Docker. You can run it from your computer. The only requirements is that you set up SSH and that you have Python installed on the control node. Ansible is a bit like Bash. You can do all this with a Bash script, only that Ansible is like 10,000 times better. You get better feedback, you get error handling, you get idempotence, meaning that Ansible keeps track if you have done these tasks or not. So when you run the same command, it checks whether the state is what you want it to be. It has a template engine, Linear 2, and as I mentioned earlier, it has support for inventories so that you can keep environment parameters in different inventories. So the structure of Ansible is that you have a playbook and you have a list of tasks that you want to run. And you can modularize this into roles. And a task is basically a name and the module that you want to call. So here we have a list of tasks from our submit role. So to begin with, we have a copy job task. It uses the copy module and copies the jar file to the driver node. We initialize the Kerberos ticket using the command module, which is something similar to a bash call. We do some debugging of the tickets. We use the template module to install the JAWS configuration files, one for the worker and one for the driver. And we use the set fact to set the name for the log. And here we do the Spark submit, which actually is a long command, but I won't show it here. You have the option to set environment variables, and we register result. Then there are some commands for handling the log, so we get the log back to the calling agent. And lastly, we want to make sure that the job fails if the result code from the Spark submit differs from 0. And here's an example of an inventory. This could be the inventory for the development environment, for example. where all the specific parameters for that environment are stored. If you're interested, you can have a closer look at this repository. It contains the complete Ansible project for submitting a Spark job. So now we have talked about how we can automate a single Spark streaming job, but we also need something to bring all the parts together. So we have chosen to use Jenkins as the glue. So with a map analogy, it's a track that takes us through the terrain repeatedly every time. So what we have done is that we have put Jenkins jobs on top of all of the Spark streaming jobs. And then when we have done that, we can chain these jobs together into a pipeline. So this pipeline, it will run a specific version of the pipeline. So a specific version of the pipeline will contain all the individual versions of all the components. So that's what it does first. It collects all the components. And then it runs all the Spark streaming jobs. This visualization is actually from the Ocean Blue plugin in Jenkins. And as I said, we have a Jenkins job for all the Spark streaming jobs, and that may sound tedious, but there is a plugin in Jenkins called Job DSL that allows you to generate Jenkins jobs. And since all these jobs are similar, there's actually only one script to generate all the Jenkins jobs. So everything is in code and everything is version controlled. But we need to verify this, of course. And to begin with, we need to verify each individual component, so that when we are in the misty forest that Sarah talked about, it's a good idea to check that the compass actually points to the north. Otherwise, we may not get out of this forest alive. But that's not enough, of course. We need to verify the complete solution, so that we don't end up at the locked gate, bringing the wrong key. So when we commit and push code to Git, Jenkins will run an automated pipeline, unit testing our code, but also verifying each component together with all the other components. So this will be some slides because this pipeline is pretty long. But basically what it does is that it fetches all the latest components. So this is the integration test. It does some cleanup. It deletes all the folders that has to be emptied. It resets all the Kafka topics. And then it introduces a test set on the first topic. Then start FUMA pipeline. That's the pipeline I showed you earlier, where it runs the complete pipeline. And then, when that is done, we can dump all the topics, as this is transparent, as I said earlier, to HDFS. And we have a test program that uses SQL statements to verify the output of each step. So that's what it does. It dumps the topics, it tests the results on HDFS. And at the end, everything is tested, and we can upload this version of the pipeline to Artifactory. So Artifactory then. Artifactory is actually the key to continuous delivery, because continuous delivery is about building an artifact once, then put it through various tests. And if it passes, you can promote it. So you need to version control binaries, and that's what Artifactory does. So now we took a long detour into the technical part of this, but we wanted to create value for Peter. So what we did was that we realized that we needed to process the position information into meaningful aggregates. So that was is what our pipeline does. And these aggregates you can show, for example, on the Power BI dashboard. So this is in Södertälje, and actually this is where we live or work, actually. And one of the sites for the pickup and delivery sites at Södertälje is chosen here. And what we can see is that on Tuesdays at noon, there seems to be some delay at this delivery location. So this is something that Peter can use to follow up on improvements at this location, so that he eventually may get rid of this particular delay. So in summary, value is always created within the business, but business knowledge in itself is not enough to describe the solution. So we and the business need to work together, and for this we need a process. And this process is enabled by DevOps, automation, and automated testing. And you should work with smart women.
And questions are welcome. There are any? Yes. Yeah, he's managing all logistics within the company. Yeah. We're working as. Okay, so our group is situated in architecture and analytics at Nexus services. So we try to cooperate with our customers as much as we can. And I think that's the thing for us that we think that will bring value to the company.
Okay.
Yeah. Any other questions? Huh? Thank you.
Thank you.